What's up, everybody? Sparrow again here from Sleepless Nights with another episode on Space Engineers Programming 101. When we left off in the last episode, we were just going over some basic stuff, like the, how the text display works and connecting it to the screen and, all that good stuff. One of the things that I had in mind for this series was doing an inventory management and awareness system where, the screen would display everything within an area or everything without your whole network, and this is like the amount of stuff that you have. But one thing that I got a lot from in the last episode was power management, so that, when you run over here, you gotta find a control station or a cockpit and get in, and then it tells you over in the right here, your power usage, how much power you have in the reactors, so on and so on and so on and so on. And so I got a lot of response from people saying it would be cool to have a script that would just tell you, you could just be like, oh, I have this much power usage, okay, and not actually, really need to look at, get in a specific cockpit or space station, control station, whatever. So I've been working on that, and other than one element, it's come along quite nicely. So here's the code in it. It's about 350 lines long, give or take. Some of it's my own notes and things that we're going to go over here in a moment. But just to show you, we're going to run it. Boom! Look at that. So the current power use is 636 kilowatts, or 637, give or take. Maximum power use is 23.4 megawatts, or I think that's megawatts. Power usage is 2.72, and you have 14.99 kilograms of uranium yet left. I think that's kilograms. That was unspecified, I guess. Reactor. So yeah, kilograms is the default. I didn't actually script that one out to where it really tells you how many, or tells you what it is on the end there, whether it's kilograms or whatever. What's the next one? I don't know. Kilograms? Grams? I think? Because that's a different measurement than electricity. I think. I don't know. I'm bad with measurements. I'll be the first to tell that. So you can see we have 4.12% power usage and 15.44 megawatts. And this is wrong. Why is that wrong? Oh, I must have not saved it when I did the older code, or when I did the different code. Okay, well, we can go through it and we can fix it as we go. So you have your void, your main function, right? One thing this script does implement is functions of its own. So here we have, yeah, here's one. It returns a string value, and it's called current power use. You'll notice it's outside the curly brackets for void. So it's called within void, but it's declared outside of void. And there's 3 functions, I think. Yeah, I'm pretty sure. So what we have here, let's just run through the gist of it, and then we'll go through the individual stuff. So this is actually just some notes that I've learned. This is a one way to access inventories. Say you have a cargo container, you declare it, or you cast it from the grid terminal, get block with name crate, and then you tell it it's going to be a cargo container, and then you store it in a value. And then you can have an owner, inventory owner, and cast crate as that, so it stores it in the owner variable. Then inventory is owner.getInventory, and this returns a my-inventory variable type, so you need to put it in a different variable. And then inventory.getItems returns a list of my-inventory items data type, so you need another variable for that. And then you can use items to access the individual slots, so that's important. This was the measurement that I found for wattage, that you have watts to 1,000 watts. Actually, I should put that in here. It's 1,000 watts is equal to 1 kilowatt, which is equal to 0.00, or 1,000 1,000 kilowatts is equal to 1 megawatt, 1,000 megawatts is equal to 1 gigawatt, gigawatt, whatever, I forget what that one's for. But this is also the breakdown that you can multiply it backwards to get the kilowatts. So 1,000,000 kilowatts is 1 gigawatt, gigawatt, whatever. I'm a programmer, not an electrician. Sue me. Alright, so variables. We have a reactor, which is... these are all declared as new lists for iMyTerminal blocks. It's basically the default block that comes out of the grid terminal system. So we have reactors, solar panels, batteries, and then display, which we cast as a text panel, and I renamed it to LCD power display. So you'll have to rename your whatever display you want to be that, or you can tweak this with the code and say like anything with type iMyText panel, you know, stuff like that. You can tweak it to where all of your displays would display it. You know, it's just how you want to do it. Okay, string reactor current, solar current, and battery current, or bat current. We also have reactor output, solar output, and battery output. These are string values that we use to identify the stuff and pull it out of detailed information, and I have a part of the code that will explain that. So grid terminal system, this is instantiating the variables, so we're actually filling the variables in with something. So we're going to do grid terminal system get blocks of type iMyReactor, put it in the reactors list, solar panels goes in the solar panel list, battery block goes in the batteries list. And these are important. These have to be case sensitive and typed that exact same way because that's their data type, not just your own variable holding them. So then we go to the power loop. The power loop is what I called it, but it's basically where we identify what power is going on at the moment. So for reactors is the first loop. So we do a for loop for integer I equals 0, and then it goes until while I is less than reactors.count, which is the amount of blocks in the reactors list that we got. So it just basically pulls all the reactors in. And then it increments with the I++ symbol to increment that variable every time you loop. So it's just going to go one at a time until it gets to the end of the list. So the current output we do if reactors, and then we, like we dealt with arrays, so we're going to put an index here of I. Detailed info is a command that returns a string of all the different information that is stored in that block. Some blocks have it, most blocks have it. In Space Engineers, some blocks do not. So keep that in mind if you get a compiler error that it doesn't contain detailed info. That might be one of those that it doesn't have. Then contains is a C# string thing that you can use for a string variable because the detailed info is a string. So it contains current output. So if that's true, if it contains current output, then we add reactor current. So that's the string that we're using up here to store the current output, plus equal, so it's going to add to, so we're not overwriting anything. Reactors, detailed info, substring. This is where it gets this is a little tricky. The substring is a string function as well, where you take the index that you want to start from, and you go. It will break off at that point and store it in a new string. So you're only taking a piece. It's a substring, as the name implies. So what we're using is reactors at i.detailinfo.index of, which is another string function, and this is the index of wherever current output is listed. Okay, and then we're adding a new line character to the end. So substring ends right here with this second parentheses, and then we're adding a new line string and then a semicolon to break it. So at this point, reactor current is only going to contain the line of detailed info that says current output, is essentially what this is saying. Okay, and then max output. If reactors.detailedinfo.contains max output. Oh, I have it in here, and reactors is working. Huh. I wonder why it's not getting the correct information then. This worked before. This line is to basically say if the reactor is on. and it's actually doing something, then calculate its max output. If it's not on, don't calculate the max output, is essentially what it's supposed to be doing, but it's apparently doing it wrong. And then it's the same kind of idea here, you're just taking the max output line. Okay, so then we do the same thing for solar panels. Works this almost identical. All we're doing is putting it in solar current, solar output, and we're using the solar panels array. It's the only difference. All the code's the same other than that. Same thing for batteries. And that stores, so these lines right here, hence the power loop, is what stores all of the current and max output for your power generating items, right? Now, this gets into the functions. So this is the display text part. So we're display.writePublicText is what's going to add the public text to the monitor, which we went over that in the last episode. Now here what we're doing is we're starting a string with these quotes, current power use, colon, space, and then closing it, and then we're concatenating or appending, depending on what term you want to use, adding to the string that we're displaying. Current power use is the function that I wrote, and then these are the arguments. It takes all three current strings for this function, so it takes reactor current, solar current, and battery current as its arguments, and then when it's done, it returns a string which will be added after this plus sign. And then we've got, I don't know why I can't scroll over. That's, okay, that's going to be a problem. I don't really know why it's not doing that, though. Let's see if we can add it to the private text here and see if it's not letting me scroll over, like, at all. Okay, well, that's going to be problematic. Text is too long. Do you want to... No, I don't. Sure, I guess, whatever. Well, that's going to be a problem. That is going to be a problem, because I can't show everything there is to these scripts if this isn't going to work. Well, actually, I kind of can. I think. Okay, so basically this is a false thing. It's going to look something like, since I can't actually do it, display write public text, and then you've got the current power use, and then you leave a space, and then when we concatenate, it's going to be the string from this that is returned by this function. So you can see this function right here. So we'll do current power use blah blah blah, you know the arguments there. Then you have a comma and false, and then close parentheses and a semicolon. So the way that write public text is, I think we've gone over this before, but the false part here is whether or not to append. So you're adding to whatever text is already written in the public text area. And then, of course, the parentheses closes the whole function and semicolon closes the line. And you can see that's kind of how this one works over here too. And this works the same way, other than the fact that we're adding a new line character so that it's down a line. Power use, then the max power use function that we'll go over, and then we're saying true because we do want it to be appended to the string for write public text. Power usage works mostly the same way, except that percentage usage is a different function that calls current power use reactor. It basically calls this and this. It calls both functions if my memory serves, but I can't see it, which is a problem. But yeah, I'm like 90% sure we can see it down at the bottom there where it's actually defined that it works. That it's calling both of those functions, current and max power use, so that it can take the max and the current and make a percentage. Total remaining uranium is used from the total uranium function, and it takes, instead of a string, it takes the reactor's list that we have, and then we want to append that as well. So I'm going to uncomment this real quick. This was a script part of the thing that I had set up to display the entire string of data and not just the not just the parts we were looking for. This part is not as pretty in terms of code. It's not as formatted. It's not formatted as nicely as you can tell, but it's because I really just wanted to get the information. I didn't care how it looked. And this was attempted display update. This was something I wasn't sure if it would work or not, but because we've talked before about, wait, 93 expected. Where's 93? 97. Oh, that is a comment. Don't uncomment that. There we go. So we've talked before about how the displays, the text panels, didn't want to update. If we just told it to run, it wouldn't change. So this function says show public text on screen and then update visual. I don't know which of these works, but one of them seems to function. For example, you can see that it doesn't have any of those listed there, but when we run it, now it does. So we've fixed that. That if at least those two lines, I'm not sure which one works, because I don't think it's this one. I think it's actually the update visual combined with this that actually makes it function correctly. Alright, so I'm actually going to use this panel and look at the information. So here's what we have, which we know these two are at least wrong. I think they're wrong anyway. So we have small reactors, we have 3 small reactors, and this is the actual detailed info without taking anything out. This is what you get when you type in detailed info or reactor.detailedinfo. You get these 3 lines: type, max output, max input. Solar panels, we have 7. You can see them here. Or 6 maybe. 1, 2, 3, 4, 5, and 6. Yeah, we have 6 solar panels. And then 2 batteries. Now the batteries have a little bit more information. They have type, max output, max required input, stored power, current input, current output, stored power. That's max. This is the current. Fully recharged in what time? And then it goes to a new battery. So there's 2 batteries based on this info. So what we need to do is look at the code and find out what it is that's causing the problem here, because technically it shouldn't have a problem. The current output is what we're looking for, which is 64, and the max output is already listed, so we just need to figure out if they're on. Let's double check and see what it's supposed to look like. It's supposed to be at 4.12% usage, and the reactors are supposed to say 15.4. Okay. So let's just check and make sure everything's on. So all these reactors are on. The solar panels are always on. You can't really turn them off. And the batteries are in recharge mode. Ah, okay, that might be the problem. That might be the problem. Let's turn them off. Yeah, okay, now it's actually active in the correct manner. It's 2.72% used and 23.44 maximum megawatts of total power. So now this is correct. So the trick here is if you haven't figured it out already, the trick here lies in the battery type being on. Okay? So the max output is only calculated into this equation if the battery is powered. However, it's powered. And we can run this again to show the difference. Right now, power is... The max power is 4 megawatts, which is where the calculation is getting screwed up because the current output is 0. But because the block is powered, it takes this into the total amount, so it changes the percentage. The power usage percentage and the total maximum power is higher than it should be because it's taking it into account because it's simply powered. That's how we have the code set up in here. Is working just determines whether something is powered or not, not whether it's actually outputting anything. So, because of that, I'm going to derp around with the code a little bit and see if I can't find a better solution for determining whether it's recharging or not. Okay, so as you can see, we finally got the right numbers up on the screen. I found an interesting little workaround to this. So you can tell from this over here that they're in recharge mode, but I learned through some Googleage that the batteries... Let me see if I can show this or not, or if it's run off the screen. It's kind of run off the screen. So right here I have not, which if you put an exclamation point in front of something that returns a boolean or a true or false value in normal terms, it will basically negate it. So what we're looking for is it doesn't contain this, not that it does. And that's the little exclamation point. So we put batteries I at index I, which is the array plus the index, dot detailed info dot contains, and then we put fully recharged in. And this has to be exactly how it's depicted in the Space Engineer's terms. So what this is saying is if it doesn't contain fully recharged in. And I found out something interesting about batteries. They don't actually have a way to identify whether or not they're charging, but when they are, it'll say fully recharged in. When they're active, it'll say fully depleted in. So that's an interesting little workaround that you can use to find out if it's charging or not. So currently, not charging, or they are charging, I mean. And you can see we're at 15.44 megawatts with 4.12% usage, which is what this says. Now, if we were to go in and set the batteries to active, this hasn't changed yet, but when we rerun it, now it's at 23.44 and 2.72, which is correct. So now it works properly, but this is an example of what I was talking about. Now it says fully depleted in 10 hours. So you can use that to identify whether or not it is in fact powering, or in use at the moment. So let's real quick run through the rest of these functions, because that's basically, you know, all the important stuff, and we can go ahead and comment this stuff. Actually, you know what? I'm just going to take this completely out, because now that I've explained it, we don't really need to display the other information anymore. So that's all good. Alright, so first off, we're going to do current power use. That's the function that determines what the current power is. So we have, it accepts a string for reactor current, a string for solar current, and a string for battery current. Now this is compiling data. What this does is I have a blank variable that doesn't define what the data type is, because this is going to return a string array. And I know that sounds weird, but it's true. It's an array of strings. So we take the first reactor current and we split it, which is a string function, by a blank white space. So basically anytime you're typing along and then you space in the same string, it's going to put this as element 1 or 0, and this is element 1. So it's basically just going to separate everything into single lines, right? So then we break all of them down into individual array components of one line. Then we have string power raw total. And what this is for is to basically just take all the information at once. Now, this is the part that gets a little tricky. So we have another for loop, one for each reactor, solar, and battery array. But we're using the reactor strings variable, which is what we stored the split data in. Now, because this is a string array thing and not an actual list like we were using before, we use .length instead of count. It's a C# syntax, it's just how it works. I don't entirely know why. So we run an if clause that if the reactor string at this index contains output, right? So you have to remember, we've already split this string up. We're only putting in like if I were to, well, actually, here's a good example. We'll go ahead and write another line here. Display write public text, and we're just going to put a couple line spaces and then reactor current, and then we'll tell this true because we want to append it. Let's go ahead and compile that and run it. Now, what this is doing is it's taking, after it's looped through all of this and determine all of the current power, what we're doing is we're just displaying that string. So we're displaying this string that we're actually feeding into this function so that you understand what data we're giving it, because that's important. So as you can see, all we have in that string is 3 lines saying current output. So it's basically saying if it contains output, which we know it's going to, then we're going to use it, because this, okay, this is going to be a little trickier. But what's going to happen here is, it took me a while to kind of wrap my head around how to make this work. But if I'm just going to work in here for a second. So we have in the current, where'd it go? Current, reactor current. Currently, that's a lot of current, I know. It contains 3 lines, all of which say current output and then colon and something kilowatt, right? And it's going to do this 3 times. So let's just copy that and paste. So this is what is stored in reactor current. Okay? When we split this, we're going to have an interesting situation where index 0 of reactor strings is equal to current. And that's it. Because you'll see there's a white space between them. And we have split them by white space. So the strings is going to look something like this. And this is an example that I didn't put in here, but it's kind of important. Actually, I take that back. It's going to be that. And this would be like this. And then this is going to be like this. Okay? Actually, I take that back. Technically, it's going to look like this. So, and then it's going to go on and on for the other 3 lines, so it's going to have multiple elements, but this one line would look like this once we've done this split command. Okay, that's important. So what we're going to do here is if reactor strings at I, which would be 0, 1, 2, or 3, it's any one of these, contains output, so it'll be equal to 1. Okay? So currently, if it's not the index of 1, this isn't going to apply. But if it is, then we know it's at output. Now we're going to do power raw total plus equals, so we're adding to this blank string, reactor string at I plus 1. So we're basically saying this. So let me just change that to a number, because that's not a good example. So what it's saying is, if it contains output, get the output, because we know that's going to be the next element in the array. So 1, or I plus 1 is equal to 2, so we're going to pull 10. Then we're going to make a space, and then we're going to add reactor string at I plus 2, which would be 3, and this is going to pull this number, or this element. Now, you might notice this has a new line break at the end of it, so how do we get rid of that? We do a substring. So it's reactor strings at I plus 2, which is the 3rd element, dot substring starting at index of 0 and going 2 characters long. So you're starting at 0, which is the beginning, and then 1, 2. So we're cutting out this one, and we're only taking these 2 letters. And then we're adding a blank space at the end, because this string is never going to see the light of day. Really. I mean, in reality. This is going to help us determine the total number of power. I think, anyway. So that should kind of explain what each of these loops are doing. It's storing all of that data into a line, a single line. I think what's happening is I put a blank space at the end because we're going to split later. Yeah, we do it down here. So power raw total is going to equal all of these from the reactor. then it's going to also equal all of these from the solar panels and from the batteries. So it's going to store all of the power data in one string. Then we come down here and we split it again into a variable called temp vals, or temp values for me. And we're going to do power raw total split. So now we're going to have the same idea that we had up here where it's all broken into an array, but it's going to be all of the power from all the three elements. And then we declare a number type variable, a float, right here. This is so we can do math, because we're going to eventually need to add all this up. So what we do here is we do another loop of integer I equals 0 as an indexer, and then I is less than temp values.length minus 1. I forget exactly why I did it that way, but I had an error when I just did length. I think it's because we go to a +1 element, and when you do just to dot length, you could be on the last element in the index, and then if you do +1, it'll say an out of index array parameter, like you're going past the amount of elements that it has in it, so it won't compile. So you do -1, so you're always one back from the end. Now what we're doing here is we're determining the measurement of power, whether it be gigawatt, megawatt, kilowatt, or regular watt. And I had to add this in here too. This was a last minute thing because I ended up getting some incorrect data because some of it was low enough that it wasn't compiling correctly or doing the math correctly. So now what we do here is values is a float, not a string. And strings cannot add, basically. Like, for example, power raw total is a string. It's just raw characters. So if we did equals 1 plus 2, this is going to equal, when you actually print it out, it's going to look like this. Because you're just concatenating the two numbers together. You're not actually adding 1 and 2 because it's a string. So you have to have it in some kind of numerical form of a float, an integer, a double, something that allows you to do math. So what we're doing here is we're doing a loop through the whole element, and every time it reaches an element, it's going to say, oh, that's right. How did I end up doing this? Oh, because of these if sequences, power raw total, all it's going to contain is the numerical data and the string that identifies what kind of gigawatt, megawatt, kilowatt it is. It's not going to contain any of that current output, max output, anything like that. It's just the numbers and just the identifiers. So we loop through, and so it's going to basically alternate. It's going to be a number, then an identifier, number, identifier, number, identifier, and that's how, once we've split this into a list or an array, that's all it's going to do. So because we know that, every time it loops through, we're asking if temp values I plus 1, so the one next to it, is equal to one of these measurements, then we take the original value, not the +1, so we back it up by 1. So for example, just so for those of you that may not be understanding everything, so if element 0 is a number and element 1 is equal to kilowatt, it's going to loop through and ask if element 1, because we're currently at 0, is equal to one of these. If it is, then we're going to deal with this one, which is the number we're actually on in the loop, and we're going to basically reduce it or add it to the point that it's a kilowatt. I did this last minute because I was using kilowatts as the main measurement, and when I added in the watts, it was just easier to bring it back to kilowatts. So everything is related to kilowatts. So what we're doing here is values plus equals, so we're adding to values because it's currently at 0, float.parse. Now what this does is it takes a string and converts it to a number, or to a float value. So because we're only dealing with the elements in the array that are numbers anyway, it's really just going to turn it into a float instead of leaving it as a string. Then we're going to do math on it depending on what the measurement is. So this would convert gigawatts to the appropriate kilowatt value. And it's going to loop through this entire loop and store all of the numbers in values. So it's not going to contain any of the identifiers, it's just the number. It's the total amount of power that we have currently outputting. Then I have a section called Set Correct Values, and it goes through and says if values is greater than 1,000,000 kilowatts, then we multiply it down to a gigawatt value, which is 1,000,000 kilowatts. And then we also change raw total. I just went ahead and used this string instead of making a new string. And we turn it into values.toString with a parameter of n2. And what this is going to say is number 2. So it's basically going to clamp it down to 2 decimal points, is all this is going to do, and rotate it back to a string. So we've done all the math that we need. Now we're going to take the number, make it a string, clamp it to 2 decimal points, and then add the appropriate identifier to the back of it. If it's not this long, and it's this long, we do the same thing but for megawatts, and the number changes to be appropriate. So on and so forth. And when you're done, it's added back into power raw total, so we return this, and this will be the string that contains a single value of 636.57 kilowatts, which is the current power use. So that's what that function actually does, and that's why we call upon it up here to do the display, is so that it will return that value next to the current power use. Max power use basically works exactly the same. All we're doing is feeding in the max output instead of the current output, so the total output. Or, excuse me, the total maximum. And we used a few different names like power max output, but the function literally works exactly the same. The math is the same. It's just determining a larger value because it's the total amount. Now, what we did up here was make sure that everything is on, so it's power, and with batteries we make sure they're not recharging before it feeds into max output so that we get an accurate amount of what the total output could be if everything was active. Now we come to the percentage use one. This is a little bit different but mostly the same. We feed in current power use and string or an output power, which we talked about is up here. The line that cuts off is because we're feeding in the current power use function and the max power use, so they're going to return those 2 values that we just talked about. So percentage use actually has the final strings. Then we make a string called percent use. We parse the data, or split, so that we can get rid of the kilowatt, gigawatt, whatever at the end of these 2 strings and just deal with the numbers. Then we make a float for current and a float for max, and we parse in the current string 0. Current string is the split value that we used. And so because there's just one element, current string at 0 is going to equal a number, like say 636.57, whatever. And then current string at 1 is going to equal kilowatts. So because we know that that's all that's going to be in these strings, we just go for those first 2 elements and ignore the last 2 because we're just looking for the numbers. So now these 2 hold the 2 numbers. Now we take the part that we ignored, the identifier, and determine the scale. So it's if this is equal to this, then we take the current and multiply it by 1,000,000 to turn it into a gigawatt. I'm sorry, reduce it back to a kilowatt. And you'll see here, else if equals to kilowatt, do nothing since it's already in kilowatt format. And if it's watts, we bump it up. So, so we're basically just scaling everything to where it's equal to a kilowatt when we're done. Same thing with this. We're basically converting them to where it's a common set of information. So if you had max output was in megawatts, but current output was in kilowatts, it would be difficult to do the math. So we're reducing everything into kilowatts. Once that's done, then we calculate it. So float total equals the current divided by the max output and then multiplied by 100, because this is going to yield a decimal place that's like 100 would be 1.00, 100%. So we multiply it by 100 so that we can bring it back up to 2 decimal points over. And then that gives us the total percentage that we need. Now we take the percent use, which is a string, and then we take the total here, go back to a 2 string, clamp it to a 2 decimal point for percentage, add a percentage symbol, and then store it in the string and return the string. And that will give us our percentage. which is what we have up here in this line. Now the uranium one is a little tricky because it involves inventory, and like we talked about up here in my notes, this is how you would access an inventory system normally. It's kind of complicated and a little more cumbersome than it probably needs to be, but it's the way it works. So right now, it returns a string, but it takes the list of IMI block terminal block, which is what the reactors are listed as. Now, you may have recalled up here when we instantiated them, we only stored things of type IMI reactor into reactors, but we define them as a terminal block list. That's so we could store anything in them. But that's important to know that you're feeding in the right kind of argument. So we start off with our variable for total uranium, which is a float value. And then we declare an owner. I did this slightly differently rather than taking the inventory and then casting it into variables. I just declared them as the proper variables. So IMI inventory owner is the variable. Inventory, and then a list of IMI inventory item type is for total items. And we declare it as a new list so that it has something in it. Or no, it doesn't have anything in it, but it's formatted correctly so that the system can use it. So then we acquire all the reactor inventories. So we loop through the reactors from the list, which is reactors.count. We've seen it before. And then we store owner is equal to, now we're casting each reactor as an inventory owner into owner. And then owner get inventory goes into inventory. Inventory.get items is added into a blank or a temporary variable called items. Now this is going to go away as soon as the loop comes back. So how do we store it? We take total items, which we declared up here as a list that's outside this loop, and we do add range and then items. Now add range is going to take this list that it gets from the get items function and add it to this one that stays constant after the loop ends. When the loop ends, we'll have a new variable that will store it, and then we'll add it to this one so it'll have both reactors, and so on and so forth, until we have all the reactors stored in this one variable, or at least the inventory. Now we loop through all of those. So we loop through total items.count, and at each index we look for content.subtype name equals uranium. And basically this is going to say if there's uranium ingots in the inventory, this is the element that we want to look at. And then we take total uranium plus equals, we're going to cast it as a float, mostly because I can't remember what amount comes out as when you're doing from a list, or this particular kind of list of these data, this my inventory item. I don't know what amount is declared as, if it's a float, an integer, whatever. So to keep things to where everything works, we're going to cast it as a float, and then take the amount of this index and put it in total uranium. So when we're done, it'll have all of the uranium added up. And then total uranium.toString, clamp it to a second decimal point. You can leave this part out and it'll just have a long decimal. You can clamp it to 0 so that it just declares a solid number. Totally your call. And then that's where we get this line at the end, where total remaining, and then we call this. So yeah, that's pretty much how we're doing it. Now, the one thing that a lot of people requested that I wasn't able to do is this thing over here where it says fuel time 3 days. The reasoning for this is that you would actually have to then take into account the amount of the bigger one is uranium, because as we've seen with the detailed info, the batteries tell you how long they have before they run out of power. The solar panels never run out of power as long as their position doesn't change. So the big elephant in the room for a code that would actually have the fuel time is the uranium, because what ends up happening is you have to take into account the uranium and then how much power it gives off per kilogram, and then you'd have to figure out how many kilograms you have, and if it's not a kilogram, how much power would it give off then? If it's a gram, how much power, things like that. You have to actually do the math on the item and how long the item will last in a reactor. And then you'd have to take that into account for three different reactors running simultaneously. It was a lot of math, to be perfectly honest. That it's doable, it can be done. I did not have the energy or the time or the patience to actually do it. I was happy with this, the way that it turned out, that you can see the current power usage. The one thing you can't see is the amount of time that it has. You could add a line for at least the batteries that says if it's fully depleted, you know, then take that information and display it on the screen as well if you wanted to. That would be purely up to you. But this will work for pretty much anything, as long as the LCD panel is titled, what was it, LCD Power Display. Then you can basically just slap this code into a programmable block and run it, and anything that's named Power Display like this will show this information. Now, one thing you can do, which is fun, that I learned how to do too, is with the timer blocks, I have this set to 5 seconds, and then the action set up to run and then start the timer. Because once you start the timer, once it gets to an endpoint and it triggers, it will actually stop. So if you put a timer block start back on the end of it, it'll start again and it'll just keep looping. So for like right now, we can start this, it'll be counting down, and then when it hits 1, it'll run, but now it'll restart again. And you'll notice nothing changed. But now watch what happens if we were to take these off of recharge. Wait for it. Wait for it. It blinks. Oh, and the numbers change. So because of that code, you could actually have this running in the background all the time if you wanted to. And if you change things, it would change along with it. Like, for example, if we were to turn the 3 reactors off. Oh, well. Okay, it does actually need power, though. And apparently the solar panels are not enough, because their current output is only... Okay, so they're not doing enough to actually function, but this is. Okay, so now... What is going on here? This got screwed up. Maybe. Ah, there we go. So the current power use... Now, the power use isn't going to change. I don't think. Wait a minute, that should change. 5.44... Power usage is 11. Oh, no. Okay, the current output is what all of your machines are drawing. That's what it is. That's why I was getting that wrong. So the current power use is 636 kilowatts. The total power that currently, with the 1 reactor on and the batteries off, it can output at 5.4, so the power usage is 11%. That's what it was. Okay. So the power use doesn't change unless we're turning off things like the assembler. Let's see how that does. I haven't actually experimented with that yet. There we go. So now it's 635 instead of 636. So that all pretty much works. So I'm happy with it. It turned out pretty good. So that's all I have for today. I apologize that this was a really long episode. I didn't really intend for it to be that long. I'm trying to keep everything in the 20-minute bracket like everything else, but when you get into coding like this, explaining all of the different functions and everything, like, it just gets time-consuming to explain everything. So I hope it didn't, you know, drive anybody crazy or anything like that. I don't know why this isn't changing, though, because I turned the reactors back on. This seems to be having some kind of issue. The timer block seems to be having some kind of issue over here. Or I could be wrong. 15.4. Oh, no. The batteries are off. That's why it didn't look right to me, but it's right. So, one last thing that I wanted to throw out there. I've been throwing it out on all of my different episodes because I have a lot of different people that watch different series, is I am thinking of consolidating some of my series on my channel. And doing less series of different games, but doing more frequently of each game. So do me a favor, if you wouldn't mind, leave me comments or messages, whatever, but let me know what your favorite series are that you really want me to keep, and order them in priority. Like, this is my top one, this has been my second favorite, this is my third favorite, whatever, however many favorites you have. Just let me know what series you want me to keep and really enjoy watching. And then if you wouldn't mind, also include what ones you wouldn't care if they went away. You know, like, I don't really watch that one, so, you know, it's fine if you don't do any more on that. That would help me out a lot in the future, because in the next, you know, few weeks or so, I'm thinking of trying to reevaluate my schedule a bit and find more time to do things that everyone enjoys more than trying to just do a lot of different stuff, and have a few people watch each thing. So on that note, also on a programming note, let me know what other scripts you may or may not want to see, or, you know, are curious if they can be done or things like that. And some of them are a little too involved that I've let a few people know that it was like, that's not going to happen, unfortunately. I'm not going to be building a Death Star that fires and blows up asteroids, or walking battle tanks that can just perimeter your base and shoot anything that moves. That's very, very complicated stuff that would take very, very long time. So let me know what you guys think as far as new projects we can do. No idea is a bad idea, but just know that they may not all happen. And then if you have a chance, I'd appreciate your feedback on what your favorite series are and things like that. But in the meantime, I hope y'all enjoyed. Again, sorry this was kind of long, but there was just a lot to go over, and I didn't want to break it down into parts. So let me know what you guys think, if you enjoyed it. In the meantime, I will see you all next time. Peace.